Good morning, everybody. I will present you a short overview of the case study for Cyprus regarding compliance of heat transmission coefficients reported in energy performance certificates in new residential buildings in Cyprus. Summer comfort in Cyprus is extremely essential, as the high temperatures experienced during the summer sometimes reach at around 40 to 43 degrees Celsius. Moreover, there are high diurnal temperature variations that occur from the highs and lows during the day, which make the need for thermal control of the building necessary. The first national requirements for the U values in Cyprus came into effect in 2007, and the result was that they made the insulation of a building mandatory. Then there was an important revision in 2010, which had as a result the compliance with the maximum average U value and a minimum accepted energy efficiency category, B category, for the energy performance certificate of the buildings. In 2013, there was a new important revision which imposed new maximum specified U values with 2 new degrees. The result was that the U values of the external walls, columns, and beams had to be equal or lower than 0.72. The U values of the external exposed floors and roofs had to be equal or lower than 0.63. The U values for the floors above spaces without air conditioning have to be equal or lower than 2, and the U values for the external openings had to be equal or lower than 3.23. The average U value for the building had to be equal or lower than 1.3. Non-compliance with input data leads to wrong reporting. Reported U values may vary from actual U values due to various reasons. For example, during energy performance certificate calculations, qualified experts may apply same U values for construction elements with different U values. Or during construction, people may use different products with worse U values than the ones specified during the energy performance certificate calculation of the building. Or there may be mistakes or omissions of building's elements during construction, which lead to a different U value than the one stated in the energy performance certificate. There also may be missing or unclear definition regarding input data, for example, for windows, doors, and other elements. And also, although in Cyprus there is a control framework regarding the calculations, as the energy performance certificate with the calculations is submitted to the authorities for building permit, there is no control framework on site. The result is that the reported performance is better than the actual performance. The scope and timing of Cyprus new data collection study. In this Cyprus case study, 25 to 30 residential buildings are expected to be studied, and now we have results for 15. They are all newly built buildings, as the need for compliance with the U values applies to newly built buildings. They are well-documented buildings, and they are in different areas of Cyprus. The targets for the timing of the case study they are collection of the relevant information, and on-site visits are expected to be made by 15th of July of 2015. The analysis will be made by the end of July 2015, and the report will be available by then. The methodology for this case study is collection of information and analysis. There will be collection of design documentation, collection of stated energy performance certificate U values for the shell and frames and the average U value of the building, collection of photographs of the examined buildings during construction phase, and communication with the architect and the tenants to check the actual construction of elements and calculate their U values. There will be site visits and inspections to check actual construction and collection of documents from suppliers regarding U values of specific elements, like windows. The objectives of the Cyprus New Data Collection Study is to provide answers to the following questions. How well new requirements regarding maximum U values and maximum average U value have been followed both in design and construction? What percentage of the residential buildings from those examined actually comply with those regulations? In case of non-compliance of maximum U values and maximum average U value with the requirements in actual construction, are there specific elements that do not comply? In case of non-compliance of maximum U values and maximum average U value with the requirements in actual construction, is there a pattern of causes for this? The principles of calculation of the U values is that the U value is actually the inverse sum of resistances of each building material and surface resistances to the outer and inner faces of the material built up of the element. The documentation per case that was collected is the U values that were stated in the energy performance certificate of the examined buildings, various photographs, and on-site visits together with statements made by the engineers and the qualified experts. So it's very important to see some of the statements made by the qualified building energy assessors who declined to provide any information regarding either all or some of their energy performance certificate. I know that some of the buildings have not been constructed as specified, and the reason is that there was not a supervising engineer on site during construction. Alterations were made during construction, but some of the energy performance certificates were not revised due to time budget reasons. When information was asked by the engineers of the project regarding the building elements, they said to proceed with the same calculations regarding those elements as the ones usually made in other projects. Now, in the buildings that energy performance certificate was provided, there are still deviations between calculated in the energy performance certificate U values and in actual U values. On the left-hand side of the chart, you can see the numbers of projects out of the 15 examined, which show the cause. The causes you can see on the chart below of the chart. So 11 of the 15 examined buildings showed that one of the causes that actual U value did not comply with the calculated U value was that there was no reliable input database. 5 of those buildings show that the cause was that there was some external elements were not taken into account. One of the buildings showed that in energy performance certificate there were applied the same U values for construction of different elements. 5 buildings show that there was a different calculation method for the U value of the ground floor than the one specified. And 7 of the buildings show that the degree requirement was not fulfilled. 5 of the buildings show that there were calculation mistakes during their energy performance certificate calculation of the U value. 3 buildings showed that there were changes during construction, but there was no revision of the energy performance certificate and its calculations. 7 of the buildings showed that there was a material was omitted in the calculations, and only one of the 15 buildings, only in one of the 15 buildings, no problem was found. So coming back to the questions that we asked before, starting with the first question, how well new requirements regarding maximum U values and maximum average U value have been followed both in design and construction? The preliminary answer that we found is that only in specific construction elements in 7 out of the 15 examined residential buildings, they have not been integrated. What percentage of the residential buildings from those examined comply with those regulations? We found that only 63% of the examined buildings fully comply. In cases of non-compliance of maximum U values and maximum average U value with the requirements in actual construction, are there specific elements that do not comply? We found that the elements that do not comply are the exposed floor slabs that are not taken into account by the qualified experts and the external openings. In case of non-compliance with maximum U values and maximum average U value with the requirements in actual construction, is there a pattern of causes for this? We found, talking to the qualified experts, that the causes for this are lack of knowledge with the result that construction elements are not taken into account, changes during construction as there is no control framework on site, and the energy performance certificate is not revised due to time and budget reasons, and that qualified experts apply the same U values for construction elements with different U values for simplification reasons. So the conclusions until now is that requested information that was not provided by qualified experts when we asked for energy performance certificate information. And the main reason that was reported by them is that the reported in the energy performance certificate U values vary from actual U values. And the causes are lack of a supervising engineer on site, alterations made during construction without the relevant revision of the energy performance certificate due to time budget reasons, an engineer giving wrong and/or deficient information to qualified experts due to lack of knowledge or appreciation of the value of the energy performance certificate. Even in the 15 examined residential buildings where information was provided by qualified experts, which are the best cases, there are still deviations between reported and actual U values, which sometimes are not so important, for example, during calculation and construction elements like the code cement being omitted, but which sometimes are very important, for example, no reliable input data, construction element like a whole exposed slab or single glazed windows being omitted, and changes during construction without the relevant energy performance revision. So this was a short overview of the case study for Cyprus. Thank you for your attention, and I will now stop and pass the screen to the next presenter.